Hello friends, I'm back with another video, and this is the video where we start getting involved into the building or designing of the agentic AI. Okay, this is the first video where I'll actually transition or let you know how system design meets an agentic AI. So let's dive in. Okay, so there's a story going around that AI agents are the brand new kind of software which is going to replace anything and everything in this world of technology, which is not true. And in fact, it is absurd. And in this video, we'll try to understand what AI agent or agentic AI brings to the table and how is it actually connected to system design. Okay, and if you have not seen my system design videos, please go ahead and check my series on system design uh, on YouTube itself. Okay, so let's start. So basically, I've spent 23 years designing systems for banks, but when I actually pulled off an agent architecture, okay, it is not something rocket science or highly complex at a high level to understand. It's quite simple. You can imagine that you have a agent. It connects to maybe a reasoning core, and then it has connections to its tools, which we saw in my last foundation video. Okay, so this is the basic agent architecture. Now, how this architecture actually aligns with the system design, we will talk about that first, and then secondly, how does it differentiate between what we are doing right now and what we are going to do when we build or design an agent. Okay, so this is how a agent normally looks under normal conditions. This is how you define an agent. Okay, so let me take the previous example which I had taken in my last video of fund transfer. Let's say somebody is doing a fund transfer over here. Okay, let's say from a mobile app. That mobile app, maybe via the internet, traverses through a web layer, reaches a app layer. This app layer connects to multiple APIs. Maybe it checks for your balance, it checks for your limits, it checks for your once it has the limits, it actually calls the core banking API. Okay, so this is, let's say this fund transfer was for 10,000 rupees. Okay, and there will be a from and to account, of course. Okay, so coming back to this CBS call, once the transaction is successful, it goes and calls an SMS API or a email API. Okay, so these are steps which are performed by your app or a service. So what we did was that last time we just replaced this part. Okay, we removed it and then we added a agent. Okay, over here I think I was calling it as a chatbot in that video, but if it's an agent, okay, this is the same thing which it can do. And in this entire process, when you're if you see at the architecture, okay, if you closely look at it, it is the same. There is a mobile app, there is internet, there are load balancers over here, there are firewalls, there are databases. So from a system design perspective, nothing is changing right now. We need to figure out that if nothing is changing, then what is changing? So are we trying to say that this agent is similar to a service or app in which we write the code? The answer to that question will be no. It is different. But how it is different, we need to figure out. Okay, because what is that special thing in an agent which makes it different? Now that is something over here, the reasoning core. Okay, let's just take an example using this same scenario or the flow. Okay, where let's say this is not an agent, this is again an application service. Okay, this application service follows that same approach, checks the balance, limits, and CBS API, and all of a sudden this API times out. Times out in the sense the request came in, CBS processed it, but it was not able to respond back to the application. Okay, you have to imagine that this is the application now. Okay, what happens is that if this application is set up, of course, in a deterministic pattern. So when we say deterministic, that means it is hard coded that okay, you do this after that. So for example, if it times out, there is a mechanism called as retry, which the service may try. Okay, so what will happen if I again draw it over here? The app, one call to core banking service for 10,000 rupees transaction. Let's say the transaction ID is 1234. What will happen is that if it times out, the app has a retry logic. But I said that CBS processed it, but then it timed out while giving a response to the app. What happens? The app will retry this again, try to push a fund transfer 1234 10,000 rupees. Okay, and in this case, since this app did something in a deterministic fashion, just calling the CBS again a second time, the CBS will end up debiting 10,000, or uh, getting the transaction executed twice. In a real world, this will not happen. There is something called as idempotency at CBS end. Okay. Okay, so hypothetically, to explain you, I'm just giving you this example. CBS will understand that this transaction has already been executed first, uh, and it will not try to process it again. That check is there. The double debit will not happen. But just for the sake of understanding, let's say that here this app somehow, because of this retry logic, is sending twice. This is how a normal application would behave. Now, when I said that we are trying to figure out the difference between a app and an agent, what agent will do? Agent is intelligent. Okay, agent is having the same flow. If it goes to CBS, okay, with the same transaction ID, FT1234 10,000, and same thing happens. CBS processes it, but not able to respond back. Okay, the agent also knows that okay, the transaction has been failed, there has to be a retry done, but before retrying it has something unique which we already saw, a reasoning core. Correct. Now this reasoning core is what actually differentiates the agent and a service or a normal deterministic app, right? What the agent can do, actually it may start reasoning over here, reasoning in the sense, okay, it will say okay, I didn't get a response from the CBS, so I maybe don't know whether transaction failed, right? This is the first part of the reason. Second, it will say okay, timeout only tells me I didn't receive a response, right? He would, agent will further think the debit may be already processed. Okay, uh, therefore I should not blindly retry. So this is the entire reasoning which the agent will do before actually making a retry, right? So this is where the reasoning code comes into picture, and this is how it is differentiated from a normal application, right? Okay, so this having this reasoning code and having this training, the agent will actually can perform an additional step. Let's say the agent can call a different API to the CBS, where it will say check transaction. What was that? FT11234. And if CBS gives a success, then the agent will know, okay, transaction already successful, don't retry. Or if it is not successful, then it will do a retry. So this is the difference between a application service and an agent. Okay, that's how you differentiate. But the point which I wanted to highlight before this itself is that you need to understand that still your system design parameters like database, your APIs, your queues. I didn't mention Kafka over here, but your web layer, your app layer, your code, everything comes into picture. Your load balancers, firewalls, everything. So it is very important for you to understand system design if you want to design an agentic AI. Uh, okay, I hope this was informative for you. Thanks for watching. Thank you. Bye bye. Hey guys, thanks for watching. If you like the video, please do subscribe, share, like, and keep watching. Thank you.